Hey everyone, and welcome. You ever listen to an argument and just feel like it's built to be right, or kinda designed to be wrong no matter what the facts are? Well, today we're gonna pull back the curtain on the hidden rules of logic. We're gonna find statements that are true, false, or somewhere in between, all because of their design. So let's kick things off with a pretty wild question. Can a sentence be true just because of how it's put together? Not what it's about, but its actual literal structure. And the answer is a big yes. And, it's a huge part of how logical thinking really works. Okay, so to really get this, we've got to grab our basic toolkit first. These are the building blocks of logic. Think of them like the little Lego bricks we're going to use to construct some really cool, and sometimes weird, ideas. First step, the proposition. It's super simple. A proposition is just any statement that has to be either true or false. That's it. For example, it is raining. We can call that P. Right now, where I am, that's false. Where you are, maybe it's true. The key is it can't be both, and it can't be neither. So our first tool in the kit is negation. It's this little symbol right here, and it just means not. It does exactly what you'd think. It flips the truth value. So if P, it is raining, is true, then not P is false. Easy enough, right? Next up, we've got conjunction. This is our logical and. Now, this one's a really strict gatekeeper. A statement like P and Q is only true if P is true and Q is true, both of them. So if I told you the sky is blue and the grass is purple, the whole thing is false, because that second part just isn't true. And here's our first truth table. Think of it like a cheat sheet that shows every possible outcome. For P and Q, just look at that final column. See that? There is only one single true result right there at the top. In every other scenario, if even one little part is false, the whole thing just comes crashing down. Now let's meet disjunction, our logical or. And unlike that strict and we just saw, or is way more forgiving. A statement like P or Q is true if P is true, or if Q is true, or if they both happen to be true. It only fails if both are false. And when we look at the truth table for or, the difference is pretty striking, isn't it? We get a true result in 3 out of the 4 possibilities. The only way for an or statement to be false is if both parts are false, which you can see right there in that very last row. All right, we've got our toolkit. Let's look at our first major concept, the tautology. This is a statement that is so perfectly built, it is logically unbreakable. It can't be anything but true. So a tautology is a statement that is always true no matter what. A classic example is P or not P. In plain English, that's like saying it will either rain or it will not rain. I mean, you can't really argue with that, can you? It covers all the bases. And the truth table really shows you why this works. Look, if P is true, then not P is false. But because we're using or, the whole statement is still true. Okay, now what if P is false? Well, then not P is true, and the statement is still true. See? No matter what you do, you always land on true. The structure makes it impossible to fail. And that's the big takeaway. It doesn't matter what pop is even about. A tautology is just built to win. It is structurally, logically, always true. So from the absolutely unbreakable, we're going to flip to its polar opposite. This statement that is literally designed to fail. This is the contradiction. It's an impossible, self-defeating idea. So a contradiction is a proposition that is always false, purely because of its structure. The classic example is P and not P. It's like saying, this shape is a circle and it is not a circle. It just makes no sense, right? It's a logical impossibility. And the truth table proves it. If P is true, well, not P must be false. And since we're using that super strict and connective, the result has to be false. And if P is false, not P is true. But again, and needs both to be true, so the result is, you guessed it, false again. There is just no way to win with this one. Yup, it's structurally doomed from the get-go. A contradiction, just by its design, is always false. So, we've got statements that are always true, and statements that are always false. But what about, well, everything else? That brings us to our third and honestly most common type of statement, the contingency. A contingency is just a proposition whose truth value is, well, it's contingent on the facts. Most of the things we say every day, like, it is sunny and I am wearing a hat, are contingencies. The truth of that whole sentence totally depends on the actual weather and what's on my head. It's not guaranteed one way or the other. Take a look at this truth table for a statement like P implies Q. Now, just focus on that final column. You see that? We've got a mix of results. Some are true and one is false. This is the signature of a contingent statement. Its final truth value isn't fixed by its structure alone. It totally depends on whether P and Q are actually true out there in the real world. So its truth value is flexible. It can be true, it can be false. It all just depends on the facts of the situation. Simple as that. Okay, so let's put it all together. A tautology is always true, and its truth table has a final column of all T's. A contradiction is always false, with all F's in its final column. And a contingency? Well, that's a mix of both, because its truth really depends on the facts. All right, so this is all some cool logical theory, for sure. But why does any of this matter in the real world? Well, it turns out that understanding these structures is actually an incredibly powerful, practical skill to have. You know, this isn't just theory. If you're a programmer debugging code, you're literally hunting for contradictions that crash your program. If you're in a debate, you can build your argument on a tautology that can't be broken, or you can spot when your opponent's argument contradicts itself. In short, recognizing these patterns isn't just a logic puzzle, it is a massive upgrade for your critical thinking skills. So I'll leave you with this question to chew on. Now that you know the blueprint for an unbreakable truth, a tautology, what examples can you spot out there? In everyday language, in advertising, maybe in political arguments? Keep your eyes and your ears open. Thanks for hanging out with me today.